Okay, everyone. Thanks for joining us for today's webcast on how IoT will impact your organization. I'm Scott Kirshner, editor and co-founder of Innovation Leader. And I want to tell you a little bit about Level Education from Northeastern University before we get rolling. Level Education was the first university-run boot camp, and it's established itself as a leader in analytics training in Boston, Charlotte, Seattle, Silicon Valley, and Toronto. It's been recognized as a disruptive innovation in higher education by the Clayton Christensen Institute and as an exemplar of higher education innovation by the U.S. Department of Education in their National Education Technology Plan. Level Education also offers programs in IoT, cloud computing, and entrepreneurship, and before long also in fintech and cybersecurity. And their website is www.leveledu.com. Before I turn things over to Kilton Hopkins from Level Education, who's going to lead today's webcast, a little bit of background on him. Kilton currently serves as IoT Program Director for the Level program at Northeastern. He also serves as the co-founder and chief executive officer of IoTracks, which provides the world with open technologies for building a better Internet of Things. And he's the creator of the Eclipse IO Fog open source fog computing technology. He's joining us today from Berkeley, California. He got his MBA from the University of Chicago Booth School of Business, and he likes to meditate, make music, and read about everything scientific. So that's a lot of information about both Level and Kilton. And I want to turn things over to Kilton. So Kilton, let us know if you can hear us and you can speak. You're out there, yes?
Yes, I am. Thank you. Thank you very much, Scott.
Okay, and let me turn things over to you so that you can show us your slides. This may take a second as we transition over, but Kilton, thanks for being here and your willingness to lead this webcast.
Sure, no problem. Thanks for having me. Can you see the PowerPoint presentation that I have?
Yes, it looks great.
Okay, excellent. All right, well, we have a lot to cover here, so I'm just going to go ahead and dive in, and then we can pick up the slack with any questions at the end. All right, what we want to do here is take a look at how IoT is actually going to impact your organization, and your organization is always comprised of your wonderful people. So that means that talking about your talent roadmap for IoT is a great way to talk about how to be impacted in a positive way instead of impacted in a very surprising and disruptive way where you lose market share and some terrible things that can happen if you don't pay attention to the new tech. So on that note then, so it's a quote that I really like, which is the CFO asks, what happens if we invest in our people and then they leave? The CEO asks, what happens if we don't and they stay? So the internet technology that we all enjoy has actually come in multiple waves. And what I want to show with this slide is the companies that are dominant in the prior wave so far have never been the companies that dominate in the next wave. And it's not because these companies aren't great. It's because these companies do what they do very well, and the new things are completely new and completely outside of their existing business models. This is how it always works, right, for new waves of innovation. Well, as we're transitioning from the what we called Web 2.0, right, and kind of the wave with social media and so on into this new era, we have to deal with physical things for the first time. And so who is going to be the dominant players in this? I don't think that we know yet. So you probably all have seen this slide one place or another, which is the total economic impact of IoT. And this slide is a couple years old, so I bet you it's even higher now, although maybe it's shifted some from industry to industry. And so main takeaway is that it's massive. So something that's not often mentioned is that the Internet of Things is actually not so much a thing in itself as it is a pathway to all kinds of new value. And one key bit of value that we can gain from all of the data we'll be gathering is the ability to implement very advanced artificial intelligence. If a city can know its flow of traffic in real time, what would artificial intelligence software be able to accomplish, right? And at the same time, we have to ask the question, then what do we do about security, right, with that flow of data? So there is a lot of different versions of the IoT stack, and but in general, they all kind of look similar to this, which is all the way at the bottom, we have some physical things and some way of doing computing there. It's often called fog computing or edge computing, and then some connectivity. Then we enter into some global infrastructure, and then we have to deal with the data. And then we actually finally are able to do things with it, such as write applications or get the data in a timely fashion to the people to make decisions, right? And then it goes up and down the stack. So what happens at the top also has to make its way back to the things. That's just on the technology stack there. So what we talk about at Northeastern and level education is how do we structure the learning? And so this T model shows what the way that we look at it is you should be able to familiar with and able to handle working with a wide range of details. And this is the bar across the top, but also deep in an area so that you're really great at least that one thing. So with that T model, we approach, education for IoT. And so if we take a look at where the money is being spent in IoT, far and away right now, it's on application development and device hardware, but system integration is coming up in a close third and growing, all the time. Data storage, security, and connectivity, that's all going to grow as IoT is implemented at higher scale. So this chart shows where you are going to get, if you're an IoT provider, where you're going to get attention right now in terms of spend, but it also shows where you probably should be spending in your company if you're about to adopt IoT at this time. So don't be sad if you're not spending that much in connectivity, you're probably right along with the crowd. So in the end, the adoption of IoT right now is already at a high rate. And as usual, as you get from these types of large scale reports, the percentage of business leaders reporting that they intend to be using IoT, right, in the near future is almost 100%, because everyone knows they want to be paying attention to it. So the takeaway here, of course, is that there's already plenty of activity, but don't be in that 4% that doesn't acknowledge IoT, and hopefully you're not. And then think about what you're going to do about it. And I'm going to outline some of those steps here in this presentation, things you can do. So there's a large skill gap. And it's estimated that in the next 10 years, we'll have a shortfall of 2 million information technology related jobs. And it's just getting worse all the time. What we need to do is be talking about how to take really great people and give them the skill sets that they need in order to be working in the new technologies and not fall behind. Everyone wants to be relevant in their work, but they also want to be relevant in tomorrow's work. And that's not something that you should be patching in real time. It's something you should be preparing for. So what the IoT skill gap looks like in particular is that we're looking at about just under 250,000 in each year through to 2022. And these are the areas where we know that the skill gap is going to be occurring. Business intelligence, obviously security, and those unique challenges for UI and UX design. I actually should say UI, UX, not UI, IX. And in particular, then also, there's a skill gap in edge and fog computing or edge and fog engineering and QA. And I'm going to outline what those things look like in just a moment here. So what does your IoT talent roadmap look like for your organization? Well, one thing to note is that all departments will eventually be impacted. That's not something that that you can change. It's very similar to mobile computing, right? With the rise of smartphones. At first, it was relegated to certain areas where they were used for operations, but now, I mean, I think we all have to admit, mobile technology has changed the operations in the business and with every department. And one way to approach it is to look at IoT readiness as the sort of thing that you can roll out through your organization in stages. How can you get, for example, awareness in before you actually get skills training? So think about where IoT is going to first impact your organization. I'll actually give a couple of different industry examples about what departments will be impacted first, so that you can, if you're in one of those categories, there's some easy answers for you. If you're not, it just should get you thinking. And then how can you understand Internet of Things before trying to solve for it, so that you, in essence, have low-cost learning to your organization of what IoT means to you through maybe some inexpensive proof of concept projects, or some training for, well, training the trainers, right? Can you send some business leaders in for training before you go and send the entire workforce in, so that that way those business leaders can understand what the impact really is and who needs to be trained up first. So let's take a look. If your company is, if your organization is an appliance manufacturer, here's kind of the order of operations there for where IoT is going to have an impact first. So in supply chain, your vendors are likely to be using IoT in some kind of an uncontrollable or unpredictable time frame. What I mean by that is, just think in your organization, do you have vendors that are more likely to implement IoT sooner rather than later? And if they do, will you be required to pick up the slack and do an integration with their IoT systems if you want to maintain the real-time flow of data and so on? And if that's the case, then how can you be planning along with your vendors in order to keep operations running smooth? Inside your own organization, if you have manufacturing of product, and that product is now going to include IoT features, and I included here on the slide a smart washing machine, right? Well, whether or not this particular model is especially smart is, I didn't do the research on that. I just grabbed a picture of a washing machine so that we could talk about it. But now, if you're going to integrate IoT technology into your existing products, the manufacturing operations may be dramatically different. So while you know how to make a great washing machine, do you have the skill set in your organization to embed the small scale sensitive electronics that are needed to do some of the IoT processing and sensing? Do you know how to integrate sensors that might be that might have failure if they are exposed to moisture and so on? Do you know how to integrate those into your product? And then, of course, do you know how to handle the flow of data and the user interface and user experience required for someone to set up your product on their home Wi-Fi? So these are all the sorts of things that now become part of product design and manufacturing operations. And from a product perspective, do you understand how your customer base is going to be using Internet of Things technology? Product design might not change very much, but maybe the first user experience is how to set up that product along with their smartphone. And if that's the case, then you have to consider if you needed some outside help to get that right. In terms of marketing, you're going to need to talk about what IoT features are really driving force for users to choose your product, and how would you present those features as a competitive advantage and so on. Now, with regard to enterprise IT, imagine now that you have your smart washing machine out and you have it out there in the hands of 10,000 customers. You now have 10,000 customers worth of data, some of which may be a bit private or sensitive. You have that data coming into your enterprise IT infrastructure. Now, the benefit here is that if you allow the business leaders in your organization to access that data, they can garner all kinds of insights, and the business intelligence possibilities are wonderful. But how do you make sure that that data, which might contain some information about your customers, is kept protected? And how do you make sure that the right data is being reported in? Because this might be the first time that you have a connected product that brings new data into your organization. This literally might be something that you've never had before, and you might even need to augment your infrastructure to handle it. And last but not least, you will have definitely some impacts regarding legal. Here's an example that with a smart home appliance. If your appliance is gathering data on your customer's Wi-Fi and reporting it to your backend system so that you can evaluate usage of the product and efficiency and so on, but it also contains some information about the customer's personal usage of the product, what data do you actually own? And what data belongs to the end consumer? And do they have a right to see that data? And if so, how do they ask for it? And how do they get it from you? And do they have the right to tell you that they don't want to share their data? And if so, when do they make that choice? And so these are all the things to consider now for your IoT-enabled product. And so this kind of view on the appliance manufacturer organization is really applicable to just about any company selling a product that now might become connected. So now an oil and gas company is a good representation of a company with critical infrastructure and remote assets. And so one of the first impacts is going to be to engineering. And that's because if you're going to add IoT technology to allow you to manage those remote assets and critical infrastructure, the integration of that technology is not going to be something that you can do just ad hoc and kind of easy peasy, right? You're going to need to have consideration from the engineers that run the oil pumps or that are involved in the management of them anyway, to say, here's how we can integrate these sensors and here's where we can attach them, and you have issues of connectivity and so on. So involve the engineers, get them trained up on IoT technology early, and that will allow you to do product or machinery integration without having a whole bunch of backfill discussions, right? Where folks are saying, well, this technology sounds great, but I don't even understand why we're doing this or that. So just involve them early, and then enterprise IT again. In fact, you'll see this across many of the organizations. So enterprise IT, in this case, it's the same old concern of security and then also infrastructure, but in essence, what you're doing is you're extending OT, so operational technology, to include a larger set of data. So where you might have used SCADA technology before to get visibility into your remote assets and their condition, now what's going to happen is you're going to have SCADA plus Internet of Things technology. And how do you merge that? And how do you merge that in the enterprise systems securely? And now you're also going to have line of business managers get impacted by IoT in a very early way. And that's because Internet of Things technology is publicized everywhere. The chances are pretty good that your customers, if you're this type of company, such as an oil and gas operator, your customers are hearing about it. And they're going to wonder, with IoT technology, what can you offer? And it's very different than a smart home appliance. You're not going to bake IoT technology into some box and then sell it. Chances are pretty good that you're going to need to attach IoT to legacy equipment that might be owned by your customer and that you might service, for example. How do you get their permission to integrate for a pilot? How do you find friendly customers that are willing to talk to you about IoT value before you necessarily have a full package to offer them? So these are line of business managers are going to need to get in early and start talking to customers ahead of time before making moves. And then, of course, the workforce. So every time you deploy a person to the field, so in some industries they call it a truck roll, right? So every time you send someone out to do some work, does this person understand what the IoT technology is doing in terms of its wireless communication, in terms of its energy harvesting, which might be solar or vibrational or thermal in order to power the sensors? And do they understand that the position of the sensors might have some impact on the quality of the data? And if they don't know these things, when they go out to service a piece of machinery, they could inadvertently shut off the IoT data that's being used to make critical decisions. So early training on the workforce there is helpful. They're in kind of sequential order, although maybe I would argue that line of business managers should be in parallel with engineering, but workforce would come after you understand, of course, what they might be experiencing in the field. So now let's imagine your enterprise, your organization is a software or pure technology enterprise. So in other words, your technology is enabling other organizations to do what they do better. So a couple obvious ones here. So engineering is going to be impacted, of course, by IoT first. That's probably because you're developing some IoT technology now. And if you can't develop it, then you really don't have much business opportunity. But right alongside the engineers are the product managers. So you might be able to integrate IoT technology into your offerings, but what does that really mean to your customers, and how does it fit with the rest of the stuff you offer? If you're a cloud provider right now, and let's say you provide business intelligence through the cloud, and you have this great software as a service product, if you're now going to add IoT to it, where's that IoT data coming from? And if your product managers don't understand your customers' scenarios, you might actually make a mistake as far as how that data gets into your system, not understanding how frequently the data will come or in what size or from what customer sources. So those discussions should be happening in parallel. Of course, marketing, because if you are offering IoT value, you're going to want to talk about why it's more valuable than competitive offerings, et cetera, and project and program management. So, the build plan for your technology products is, and whether it's hardware or software or both, is going to involve, or already involves, all the great know-how of your project and program managers. But if they don't understand Internet of Things, then they might be misunderstanding the timelines that are going to shift. And we will talk about kind of the shift in timelines in a minute here, but they might misrepresent the timeline for a project, because IoT involves hardware and, or often anyway. And if you've been dealing exclusively with server software up until now, or cloud software, the deployment of hardware just might be something completely unfamiliar to your folks in project and program management. QA will definitely be impacted, and it's a similar thing. I'll talk a little bit more about this, but maybe you're looking at devices and hardware for the first time. Of course, cybersecurity goes without saying. This should be high on the list for early IoT training. And then, of course, architecture. So the types of data that IoT brings is very different than the type of data that you get from, say, REST API calls against social media systems. It might be coming in a matter of gigabytes every day if you really have a lot of data streams from IoT. And how do you architect for that in your product and your backend systems? So, okay, so let's talk about the impacts to enterprise IT. So we talked about the need for security. We talked about the need for being able to handle the incoming volume of data, but let's talk about the ownership of the data. So in enterprise IT, you manage infrastructure, and you manage to an extent the architecture that goes into the products, depending on how much enterprise IT is the kind of the back end for the products directly. And you also have to manage business stakeholders. So when requests for IoT data come in from a department that doesn't really have ownership over a particular product's business operations, you now have to be the man in the middle there to say, well, the access to that data is kind of, it involves customer sensitive information and so on. Let's talk about who should access what pieces of data, and then how do you provide that infrastructure? So it's not really a trend that's happened yet, but in the very near future, it's a prediction that you'll see enterprise IT or enterprise IT architect now have titles that might read enterprise IoT architect or enterprise IoT. And they might be running in parallel with existing enterprise IT, but this is representing just how central enterprise IT is to the Internet of Things revolution. And so one thing to consider is, up until now, enterprise IT has been looking at infrastructure as a data center or outsourced data center, and you have asset management involving things that are largely connected, but don't involve a whole lot of setup on a per user or per customer basis, or a per deploy, or how should I say this, on a per project basis. It's centralized infrastructure up until now. So when you rack some new servers and you get the database software running on that, you put the SAN in place and all of this, you're serving a whole lot of usage with that one effort. IoT is unfortunately different. So to deploy sensors to, let's say, one of your company's warehouses, and if you're in enterprise IT, you will most likely be involved in this, you might be deploying 10,000 sensors across 4 warehouses over a span of 30 days. 10,000 sensors versus what would have been maybe in the past 4 to 12 servers or pieces of hardware in the data center to execute a project. So just consider the scale of and the costs of install and setup. The products that you choose for your IoT systems can have a big impact on the cost of install and setup, and that's kind of the key takeaway from this. And so you might be buying now from new vendors, vendors that you're literally bringing in just to get their IoT technology, and otherwise you had no reason to buy from them in the past. So the onboarding of new vendors, might be something that is a bit of a bottleneck in terms of process. And if you need to procure at large scale, you might need to ask the vendor straightforward, well, we've never bought from you before, and we buy at high volume. Are you able to supply us a quantity of 40,000 of these devices for us to do full scale rollout? And if not, when can you provide that? So some key questions to be asking. And you'll be dealing with new types of networks. So up until now, you've probably been dealing mostly with TCP/IP oriented networks. And in the mobile era, you now have come on to dealing with cellular connectivity and how to deal with VPN connectivity over cellular. And all of this stuff has been, the last 8 years or so. And now you'll be dealing with networks such as, chained mesh networks that are, using Zigbee wireless or Bluetooth low energy, especially if you're in healthcare, because healthcare involves a lot of wearable technology. Bluetooth low energy is one of the most common modes of communication for wearables. So, and then also, over the long range, in the past, your WAN might have been driven by cellular or satellite or point-to-point microwave or leased line. And now you might have a long-range, low-power wireless network for IoT, such as LoRaWAN or Sigfox, and or you might be using LTE-M, which is an upcoming cellular technology. There's several of them, by the way. So you might be using that for IoT connectivity, and it involves a different type of agreement with your carrier. And so these are just things to consider here on the types of networks you'll be facing. And so with all of the hardware that you have to roll out, sensors, the sensor driver boards, the wireless base stations, all of this, you're looking at new capex. And the payoff of that capex is, in some cases, a very clear ROI on a per project basis. And in other cases, being enterprise IT, you have to take a look at the long run. So what about 6 years down the road, having the right IoT infrastructure for your organization so that you can deploy new sensors without deploying new wireless base stations? So in other words, without deploying new network. If you think this is going to be important, maybe talk about it today. And this is where IoT training can, of course, help very much because you're able to ask the right questions early. And you're going to have involvement in facilities for probably the first time in, maybe 10 or 15 years. And here's what I mean by this. As the move to centralize into cloud architectures or bigger centralized data centers, as that has taken away the need to be involved in specific facilities on a day-to-day basis, now with the involvement of sensors and new hardware and IoT devices being implemented in physical locations, there's now a heavier amount of involvement of enterprise IT with direct facilities. And that's manufacturing facilities, supply chain storage facilities, warehousing, whatever it might be in your particular organization. You might find yourself needing a direct contact on the ground more than you did in the last 10 years. And so for the first time, this is kind of a funny phrasing of it, but we now are not able to just throw larger physical hardware at the problem. So whereas in the past years, it's been very fashionable and appropriately so to make as many stripes and as much virtualization or containerization as you could out of the enterprise hardware that you've acquired. Now what we have is the need to do load planning again, so that you know how much processing is taking place in a particular facility. So in a light manufacturing facility that's owned by your organization that might be located 20 miles away from the heavier manufacturing facility, so this is like maybe prefab of some components, do you really need a $15,000 server there for the streaming IoT data to do the edge processing? Possibly not. So can you limit the cost to maybe $1,200 for some light IoT pre-processing there at the edge? These are the questions you want to be asking. And how do you do load planning as the sequence of IoT data as it streams through your architecture? And legacy integration is going to be one of the biggest challenges for maybe even the next 8 to 12 years. Let's say you have RFID in your warehousing, in your company's operations right now, chances are very low that you're going to do a greenfield installation of new IoT technology. You're most likely going to try to leverage that RFID technology in any way possible. It was probably a high cost. It's probably great technology that has a long lifespan, and you're maybe just 2 years in on a 12 to 16 year lifespan of that technology. How do you integrate with it? And the earlier that you can start planning IoT integration for legacy stuff, the smoother it's going to be in the coming years. So now, outside of enterprise IT, let's talk about an area that almost never gets coverage with IoT, but yet is going to be impacted so quickly that I wanted to really put it here as like a red flag warning in this webinar. So the impacts to QA. So very few companies that deal with software products today, or who deal with what I can call like non-connected products, very few actually have dealt with actuation in the past. And so now what I want to say here is, so actuation, to define, it kind of succinctly, is the ability to remotely impact the physical world using, whatever backend signals or messages or commands you might issue. So if you have a smart washing machine, or I should say, if you have a washing machine as your product that you offer right now, and it becomes a smart washing machine that's IoT connected, you might be able to force a clearing of some error codes and a reboot, or force a shift into, call it kind of like easy operation mode if your customer is having troubles, and do this from your home office. So if you can change that connected product's functionality remotely, that's actuation. If you can close a water valve by 20% remotely, that's actuation. And if you're doing actuation for the first time, does your quality assurance team have any understanding of how to test this and the impacts of changes to software? Do they have an understanding of what physical world impacts might be produced by changes to code? So just wanted to bring that up. And that's pretty much what I was just saying, is you can verify information, but how do you verify that your new production release of your firmware for your connected product, or your software that does, edge processing on an oil pump, how do you verify that it actually is doing the actuation or changing the physical world in the amount that you planned? This is a very difficult problem to solve. So do you need to put a QA person out in the field to take a look at, let's say, a transformer station, if you're doing energy grid, and that's your business? Do you need to put a person there to verify the production release of some IoT technology? Or is there a way you can put some monitoring there that doesn't involve sending a person? So I wanted to talk about, a really good example of what it is to do QA testing with IoT. So you might need specific hardware. And so there's actually a really good opportunity here for any QA professional to not only train up, but have a broad range of new expertise. So now, how do you test something? I have an example picture here of the Tile device, which is, Tile will help you find things like your keys. And because with your smartphone, it can use Bluetooth Low Energy to see where is that tile in my environment. But they also released a feature now which you can use the Tile to find your smartphone, and that's where you tap on the corner of the little Tile device. Well, in doing QA testing, you just, if you're the company that makes this, if you're Tile, you just went from having the Tile emit information, which is pretty easy to simulate, to now having the Tile have a button on it, which is actually doing some actuation in reverse. The Tile actually actuates a smartphone and tells it to ring, or whatever it is their product does. So how do you test that? You probably need to have some physical testing of button pushes on the little Tile product. Do you want a bunch of people sitting at a desk tapping buttons all day? And how do you do automated testing with a physical product where you have to push a button? Maybe some specialized machinery, and where you could essentially have an automated button pusher that will test the different physical product models that you've released to your customers. And so the provisioning and deployment of your hardware now need to become part of testing, because if when you send your customer an IoT product, let's say it's a sensor for refrigerated freight, and your customer is they do the logistics of this, and you're providing the technology to measure the temperature as freight goes through this cold shipment. The provisioning of the sensor to a particular shipment is something that your customer is going to have to do. And if you don't test that that user experience as part of your QA process, you might find that when the customer gets it, it's dead on arrival, and they aren't able to provision it to a shipment. Knowing that ahead of time can save you a ton of money because you're shipping physical products now. And if that's not something you've done in the past as a software company, think about just how expensive that could be if you get it wrong. And think about scale. So how do you test tens of thousands of devices? Whereas, in the past you could simulate server traffic flow. Can you really simulate a sensor data flow? So now let's talk about some of the impacts to engineering. So sensors and devices are going to change after you deploy your IoT technology. This is just a fact of life. And so if your engineers are very familiar with a particular model of sensor that you've purchased for your first IoT deployments, that's great, but do they have an understanding of maybe some of the competing models? Or how do they keep up to date with new sensors and devices that are emerging in the market? Because they'll need to interface with those instead of just the initial ones, maybe 6 months to a year after deploy, sometimes even earlier. Sometimes 2 to 3 months after deploy, comes a request from a customer to add new devices to the system. So that's just something to consider early. And so now, Scott, what I want you to do is step ahead in these slides, just as I kind of talk through, and we'll have some fun with it. So data modeling it was something we used to have to deal with. And the great thing is that REST APIs are beloved by engineers everywhere, and it makes it easy to grab data. IoT devices do have APIs, but let's take a look at the next line. But unfortunately, IoT devices do not have REST APIs. They have very challenging APIs, and so we get the frowning cat. And so what the disapproving cat tells us is that engineers have enjoyed for the last 5, 6, a little bit longer than that actually, for the last number of years have enjoyed much easier system integration or inter-system integration thanks to REST APIs and other common models. IoT devices are kind of back to the drawing board. You have to take their data in raw binary form and model that data in a way that integrates with your backend systems. And all of this is now like a lot more engineering effort to do integration than we had previously dealt with. Now, the value of that IoT data should be very high, right? And once you get it right for one model sensor, you don't have to do it again. But just think, how can you get your engineering staff ready for this type of integration and data modeling so that they can think ahead on architecture and so on. So similar to QA, the impact to engineering here is it's very difficult to simulate scale. Well, what if you're building data ingestion where you do some pre-processing and real-time normalization of the IoT data? And so let's say that you simulate the load very effectively because you wrote a simulator of some temperature sensors. And then you say, now, okay, simulator software, let's test our code that we wrote and simulate 10 million of these sensors chirping data at once. That's fine. But did your simulator take into account the type of junk data that you get from a bad transmission in which you're missing the last 2 bytes? So when you simulate scale, you're not just simulating load, you're simulating all of the anomalies that you get with a very wide distribution of a sensor hardware. And that's very difficult to predict because, well, we kind of don't know what we don't know. We don't know what's going to happen at scale until we've tried it. And so now you'll have new environments. And this actually, it impacts in engineering, it impacts QA, it impacts operations. So network operations center, it impacts, the OT team. How do you have a development environment that involves hardware? Well, if your hardware that you're building against are some sensor boards that cost only $25, that's not too big a deal. You can give some to each of the developers to build against. What happens if your technology that you're building against is actually a $400,000 high-speed, long-life engine that is used in manufacturing, electric motor? You can't really be going and putting $400,000 motors that are fully outfitted with sensors into different development environments so that your developers can work on multiple releases simultaneously. It's a precious asset. And so how do you allow developers access to the hardware to do their work? And the same goes with testing. And how do you simulate enough scale without then essentially being your own customer, right? And establishing large environments to use for testing. This is a challenge that has not yet been addressed in most organizations. So think about it now. And then what do you do about production? So do you give remote access to the development team that's on call when that remote access now means that they could effectively shut down manufacturing for the customer if they make a wrong move? It's a little different than production access to data, in which it's kind of clear whether or not you're manipulating data. But you could inadvertently send a signal that powers off a piece of equipment and not really understand it unless you're trained ahead of time. And then what does deployment look like as you move from dev to test to production? Is something to talk about. And this impacts project management and everything too. So impacts to product. I'm going to move a little bit faster. I think first I thought we had too much time available. Now I think we have just barely enough. So let's go next slide. Your estimates are going to be way off. And that's in terms of time frame as well as cost. So be aware of that ahead and start learning about IoT so that you can get those estimates down in relation to your competitors. You want to be closer. And so your setup and deployment of your products or your services that involve IoT technology, this will be the new first impression that your customers have. And so how hard is it to set up that smart washing machine or that smart dishwasher? That is now the new customer first experience. In the past, it was the first time they washed the dishes, but now it's the setup of the device on the Wi-Fi. And if you don't get that right, it could be very frustrating for your customer. You now have to consider liability. So we talked a little bit before about the legal aspects of who owns the data and how do you reveal what data to what parties. But also think about if your connected product now is unable to perform its primary function when the Wi-Fi goes down because of a bug that's in your IoT sensor board firmware, are you liable for the loss of use of the product because you released a new firmware edition, a new firmware version that took it offline? It's quite possible, yes. So consider it now. And now for the first time, if you have been a software product company, you now have real capital outlay. If you're going to send, well, let's talk about insurance, the insurance industry. So up until now, your sources of information were largely coming from, I wouldn't call them outdated sources, but I would call them standard industry sources of information about, driver behavior, changes in, per locality and accident rates, and all these sources, all good sources still. But now, if you're going to get real-time information about the how much a driver is driving and where they tend to drive, is it always kind of the same path, or as a commuter, or is it different? You're going to need to send your customers some hardware. And also, if you're in energy, so let's talk about a company like PG&E or Commonwealth Edison. These companies might send a Nest thermostat, which is an IoT device, to the customers in order to be able to get better data about temperature settings inside the home during the busy seasons, so cooler in the summer, warmer in the winter. And if you're going to send that out, you're going to have to pay for it. No one's going to give you that IoT hardware for free. So you might have real capital outlay involving your product or service for the first time, or for the first time in a long time. So IoT interaction is very different than standard technology interaction from the last years. You might not have a keyboard or a screen at all. And so how do you let the customer know? A good example of this would be like maybe a connected smoke alarm or fire alarm. So it's not going to have a screen. And even if it does have a screen, no one's going to stand 12 feet below it and looking up, squinting to see what's listed on the screen. So how does that connected product tell you what it needs to tell you and allow you to interact with it if you don't have the same old model for your tech? And now if you are in product, your product in the past might have been not needing to gather any data and therefore not incurring any kind of back-end costs. So let's say now that your connected product that you release is gathering data and storing it in the cloud. Cloud systems are wonderful, but they can also be costly. So just beware, you might be accumulating a very high expense on a monthly basis for all of the IoT data. Is there a way that you can mitigate that early before you end up spending all of your new return from your connected product on the cost of that connected product? So let's talk about, and this is so we're at the end here, let's wrap it up. Let's talk about an example IoT program that we did through Level at Northeastern. So we did a 15-week program that was hybrid learning, and we did one in-person session per week, but then the students have done 6 to 10 hours of online study per week, self-paced. And then also 8 to 12 hours of hands-on lab exercises per week. So in other words, we meet for one night a week, and that's so that there was no break in employment flow, right? So just don't change anything about your day job, but get trained for that day job in IoT by coming to class one night a week, and then the rest of the time it's up to you to schedule it, how you do the work. And so kind of the purpose of this is to level up the existing talent in an organization. And it's not going to get anybody ready for a specific IoT deploy. It actually, this program goal was to turn the wide range of students into IoT thinkers with enough practical experience to say what is and is not feasible for their organization. And in the program, we went all up and down the IoT technology stack, which I showed you earlier in this webinar. And we went typical T model here. We went deep enough in each topic to produce insights, and broad enough to be able to say, I understand the flow of all of it, with each student then saying, I would like to dive deeper into the following areas, and they're able to leave this program knowing where they want to learn more or become maybe a specialist. And it might be related to their prior, their current career, or it might be a shift. Maybe someone in project management is entering into product management by understanding how to make a great connected product. And at the end of this program, we've done capstones that tie directly back to the employer. And so that's so that an IoT proof of concept can be done by the students that enter the Level program as part of their way of not only proving their final experience for their final grade and graduating from the program, but also to bring immediate value back to the employer that has sponsored the education. And that's what a bit of it looks like in practice. And there I'm with some students, and this was early in the program, and we were doing some hands-on work with Bluetooth Low Energy, and that led to some great future lessons. And there we go. So that's in essence my big brain dump of how IoT is going to impact your organization and organization that is similar enough to your org to get you thinking. Some of the things that we're doing at Northeastern through the Level program to get people ready for IoT. And I guess it's a good time for questions.
Okay, Kilton, great. We've already got a couple questions that have come in through the chat interface. And so in our remaining 6 or 7 minutes, you can ask them through the chat interface, and then I'll also unmute everybody in a second. So you can ask them the old-fashioned way if you prefer. The first question is just, how do you think about companies trying to transition off use of external consultants or consulting firms towards developing their own talent? My company believes that developing our own talent may be too time-consuming to move quickly. So that's kind of an interesting question about once you start using outside consultants to develop IoT hardware or software, maybe making the case that you should be developing these skills internally.
Yes, so I have a lot more that I could say about this, but given the time constraints, I'll just put in a couple of key points. The outside consultants are going to help you understand the lay of the land, and there's more value than just not having the skills in-house. You just simply can't have the broad range of experience that outside consultants get. So there's always value there, and I think in areas of new tech, good stuff, right? It's a good idea. But now, how do you know that they are providing you with the right architecture for your IoT future? You got to have people inside your organization that are trained before you get really deep into some production deployments, right? So while you're at the POC phase, get people inside your organization who understand IoT inside and out, because otherwise you won't be able to assess whether or not they're putting in place the right pieces. And now what happens if a year down the road, your IoT deploy, which was great in year one, now goes overseas to your facilities there, and it just can't work. And it's because of some short-sightedness in terms of the architecture regarding this, the cellular band, or the just the sensor models and their need to connect to some infrastructure that doesn't exist in your other locations. So somebody should be able to keep an eye on what's happening at a minimum. And I would recommend, of course, to have, as I pointed out, who early in your organization is impacted by IoT, have them trained enough that they can tell what's going on. So the external consultants are a great way to get stuff done and to get projects off the ground. But if your business line manager doesn't know IoT well enough, they might not even know the right questions to ask of the external consultants. You might be leaving money on the table in a lot of ways, in terms of uplifted revenue or in terms of decreasing costs where you just didn't know what to ask. So that's my kind of 2 cents, my quick version on that.
Great. And the next question is kind of about making the case for industrial IoT. And this person points out that so many of the flashy products we read about are connected thermostats or light bulbs for consumers. Are there any resources you'd recommend for an organization that's trying to make the case that industrial IoT is worth doing?
Oh, absolutely. So industrial IoT is actually the focus of the programs that we teach at Northeastern level for, multiple reasons. But the most baseline reason is industrial IoT is the most demanding version of IoT that we have. Things move at a massive speed, and the volumes of data are high, and then the stakes are very high because if you do any kind of automation, right, you can lose real product off the assembly line and so on and so forth. So how do you make a case for industrial IoT being of value today, right? Not just pie in the sky or something down the road. Take a look at the way that GE has modeled it. So at GE, the work that they're doing is they have been very vocal about the shift to a data-oriented company, right, and becoming all about information versus just about the hardware. They're aiming for a 1% improvement in operational efficiency of the products that they offer their customers, and that has justified billions of dollars in expenditure. And so 1% over the lifetime of your manufacturing facility might not be enough for you, but is 5%. So just what you want to ask yourself is do we have an ROI that we can approach today? And if that ROI involves IoT infrastructure, which is maybe a little too expensive for just that ROI, does it now open up the opportunity to do 4 or 5 other high ROI use cases over the next 4 years? If so, then it's kind of like installing telephone lines into a facility, maybe when you don't have that many calls going through at first, but then 10, 15 years later, you realize that the flow of business is now done by telephone. IoT is the same way. You're going to need infrastructure. Mm-hmm. I recommend the Industrial Internet Consortium as a place to look to with regard to seeing how testbeds operate and reference architectures and security recommendations they publish. And of course, you can get a hold of more information if you're a member, not advocating for any particular membership, just saying there are consortia out there that focus on exactly this sort of thing, which is proving why industrial IoT needs to start happening now.
Mm-hmm. Let me unmute Denise, who I think has a question for you. Denise, you are unmuted and can ask away.
Thanks, Scott. Kilton, great presentation. My head was spinning with lots of thoughts as you were presenting. I had a couple of questions. Well, one, there are observations from being on the healthcare side. As IoT rolls out, I can see if we don't set up some rules of the road that everybody engages in, as interoperability takes hold, we could have all kinds of issues that we're dealing with. And I wondered if there's a consortium that's really trying to focus on that. And then my second part is, do we think blockchain could help with some of the security side in the underlying architecture that blockchain presents? And I wonder if there's some thought that's been given to that. Thank you.
Great. These are
great questions.
Sure thing. These are excellent questions. Yeah. So first, regarding interoperability. So all of the IoT consortia are dealing with interoperability in their own way. Testbeds are a very common model for figuring out how to deal with it. But I will say one thing on interop. Choosing a common protocol for the flow of information does not give you interop. That's like saying that two people who can speak French are able to get along. They can communicate, but do they really exchange meaning with each other? And so a common protocol sets some groundwork, but it doesn't solve it. And that means that your architecture needs to consider, how can you use software, maybe processing right there at the edge where the two devices are talking. In healthcare, you need to be at the edge because sensitive information it usually can't leave the building, right? At least not until it's been dumped into the proper HIPAA compliant systems and so on. So how do you do interoperate there in the patient's room? And one way to do that might be to say, well, what if we use software? So that's the rise of edge and fog computing, which are synonymous terms essentially when it comes to IoT. Maybe we can do the processing right there to allow them to talk to each other. So think about interop in terms of the flow of data before you think about it in terms of like one large application that manages everything. To say, if these two things can talk to each other, how do we allow them to exchange information without that leaving the room? That might be a good way to break it down. And then with regard to the second part of the question on blockchain, there are actually quite a few organizations looking at blockchain's applicability to IoT. The thing to consider is, with every blockchain system, the highest level of security comes from it being widely distributed across the globe. And if it's widely distributed, you have a pulse to it. So one of the fastest pulses of blockchain systems is Ethereum system that goes at 15 seconds on average per block. If you can wait 15 seconds to get a signature locked into the blockchain for the recording of data, then you might be golden in terms of IoT applications. But if you're moving at the order of 100 microseconds per data message through your manufacturing system, blockchain won't help you, but maybe you can aggregate the data and maybe once every 20 minutes put it on the blockchain. So that's just something to think about with blockchain's applicability.
So blockchain might work. So blockchain might work in certain kinds of situations.
That's right, exactly. And especially if you have a large value transaction, such as the turning off of a generator, is not the sort of event that you want to take lightly. So if that's key to your operations, maybe record that event in the blockchain so that even if you have a failure of your IoT data storage, you know that that event occurred at this particular point in time and it's irrefutable, right? So one of the things the Industrial Internet Consortium lists as a key metric for, it's actually in their IoT vocabulary listing, is something irrefutable. And what does that mean? And so, and there's actually, I think they even use a different term for it, but once information has been recorded, can it be changed later so that history is altered? It shouldn't be, because the sequence of event was involving physical goods. So it's something to think about. Blockchain's good for that.
All right, in interest of time, we should probably wrap up, although I think there may be a couple more folks who have questions. We're happy to give you Kilton's contact information in our follow-up email. And certainly if you just want to email me, scott@innovationleader.com, I can make an intro to Kilton and the team at Level Education. I should mention before you log off that we're going to be hosting another webcast with Level Education from Northeastern University on July 18th at 1 p.m. That's going to focus on automating data flows and getting to valuable insights for innovation faster by automating data flows. You can register for that at innovationleader.com and look for webcasts under the events menu there. I just want to thank everybody who dialed in and logged in today for this webcast on the impact of IoT, and especially thank Kilton for spending some time with us. You were fantastic, and we really appreciate it.
Oh, thanks so much for having me.